Today we're going to do 2.5, solving other equations algebraically. We're going to finish it up working with fractions and absolute values. By the way, this is not Mr. Yang. So let's go ahead and jump into involving fractions. We're actually going to be working with equations that have a bunch of fractions involved. And in order to make them easy, we want to get rid of them like we always do. So example 1, we're going to have 1 equals 2 over x plus 3 plus 1 over x minus 1 minus 2 over x squared plus 2x minus 3. Now looking at this, it's obviously not the most pleasant thing to work with, but we can actually make it a lot easier. The best way to work with equations that have fractions is to multiply everything by the LCD. So multiply everything by LCD. Okay. In some cases, your LCD is actually going to be pretty simple, but with this one, it's going to be a bit longer. So here, I see that part of my LCD has to include x plus 3. The other has to be x minus 1. Now, looking at this one, x squared plus 2x minus 3, I should notice that it's actually factorable. So x squared plus 2x minus 3 factors out to x plus 3, x minus 1. So because it's the exact same terms as what we already have in our LCD, we don't need to multiply it by it again. We'll just use this as our LCD. Alright, so we're going to go ahead and multiply all of that, x plus 3, x minus 1, times everything in our equation, including that constant on the other side. So what we're going to do now is basically get rid of basically all of our denominators by distributing these two terms into each one of these. I'll go ahead and show the work this time around, but you should notice that essentially you get to cross out whatever is common, such as the x plus 3 and the x plus 3. Again, I will show it this time. So 2x plus 3, x minus 1, all over x plus 3, plus x plus 3, x minus 1, all over x minus 1, and then squeezing in that last one, minus 2, x plus 3, x minus 1, all over x squared plus 2x minus 3. Alright, so I'm going to go ahead and cancel out what I can. Notice that when I multiplied by everything, I wasn't actually trying to get a common denominator, but I was multiplying the numerator by my LCD. The reason is because I want to cancel these out. I want to cancel that out. And I want to cancel this entire thing out. Over here, I'm going to go ahead and multiply out and expand these two binomials. So I get x squared plus 2x minus 3, just like before. I have 2 times x minus 1 plus x plus 3 minus 2. Okay, now we just have to go ahead and simplify. I'll keep everything over here the same. X squared plus 2x minus 3 equals 2x minus 2 plus x plus 3 minus 2. Let's see, so this can be combined. 3x negative 2 plus 3 minus 2, that's going to be minus 1, all equal to x squared plus 2x minus 3. We want to set these equal to 0 just like before, so I'm going to subtract 3x, add 1, so subtract, so minus 3x plus 1. Okay, so we have x squared minus x minus 2 equals 0. We have a quadratic. I'm going to solve by factoring. X minus 2, x plus 1 equals 0. Meaning that x is going to be equal to 2 and negative 1. Now here's the thing we need to make sure of before we actually just say, okay, that's my answer. I need to check up into my original problem, 2 over x plus 3 plus 1 over x minus 1 minus 2 over that entire trinomial. I need to check, what is my domain? My domain basically says that x cannot be 3 or positive 1. Luckily, none of our answers came out as 3 or positive 1, so these two answers are fine. We do not have any extraneous solutions for this problem. Alright, so that's how you would work with something involving fractions. We're going to go ahead and move forward now into solving one that involves absolute value. So let's go ahead and set that up. So involving absolute value. Right, so our example for this one is going to be the absolute value of x squared plus 6x equals 3x plus 18. Whenever you have an absolute value type equation, you actually have to break it up into two parts. The first one is just whatever you see inside, so x squared plus 6x, and then it's going to be equal to the same thing, 3x plus 18. On the other side, you actually have a second equation. That one's going to be x squared plus 6x, but the opposite of all that. Still going to be equal to the same exact answer. Okay? Reason being is when you take the absolute value, you always end up with that one answer, such as the absolute value of negative 2 being 2, absolute value of 2 also being 2. So we want to make sure that we take the absolute value of the positive version and the negative version. Okay, so let's go ahead and do the one on the left first. So we have x squared plus 6x equals 3x plus 18. Best thing to do here would be to set my entire quadratic equal to 0. So I need to subtract 3x and 18 on both sides. Therefore, I get x squared plus 3x minus 18 equals 0. It is factorable, so I get x plus 6, x minus 3 equals 0, meaning that I get x equals negative 6 and x equals positive 3. Okay, that's our first set of answers. Over here we're going to do the same thing, but we first have to distribute. Negative x squared minus 6x equals 3x plus 18. I personally do not like working with negative x squared, so I'm going to actually move that one over, as well as that 6x. So here I get, let's see, 0 equals x squared plus 9x plus 18. Okay, so this one is actually also factorable. This time I'm going to get x plus 6 and x plus 3 equals 0. Meaning that my solutions for this one I'm going to write in black. X equals negative 6 and x equals negative 3. Notice that negative 6 repeated, so we only need to state it once as our answer. However, the thing that we have to check for here are the extraneous solutions. In absolute value type problems, we have to actually plug it back into the original problem to see if each one works. So let's go ahead and check for negative 6. Negative 6 plugged into the original one, so we have negative 6 squared plus 6 times negative 6, absolute value of, and then 3 times negative 6 plus 18. Okay, so that's going to give me the absolute value of 36 minus 36, negative 18 plus 18. So I get the absolute value of 0, 0, and because 0 is equal to 0, negative 6 works. Next we try positive 3. So same deal, 3 squared plus 6 times 3 equals, let's see, 3 times 3 plus 18. That one is going to be 9 plus 18, absolute value of. And over here we actually get 9 plus 18 as well, so we know immediately it's going to be the same thing. And then finally negative 3, plug it once again, negative 3 squared plus 6 times negative 3. Now looking at this, it might seem like it won't work out, but remember we're actually taking the absolute value. So negative 3 squared, that's going to be 9 minus 18, absolute value equals negative 9 plus 18. Absolute value of negative 9 equals 9. and 9 equals 9. Alright, so all of these solutions did work out. We don't have any extraneous solutions once again. So my final answer will be x equals -6, 3, -3. Okay, so those are the answers for that one. If you have any questions, go and write in the Cornell notes in the question column. See you tomorrow, and once again, I am not Mr. Yang.